Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of the electronic circuit and we are discussing the various components of the electronics which used in the electronic circuit. So today's topic is the power supply, that is also a important part of the electronic gadget. So what type of power supply we use in which instrument and what type of power supply we have, how many types, how we classify the power supply, we will discuss in this lecture. So first we discuss that what is the power supply. The power supply unit is a part of the hardware that is used to convert the power provided from the outlet into a usable power to many parts inside an electrical devices. Every energy supply must drive its load which is connected to it. Depending upon its design, a power supply unit may obtain energy from the various type of energy sources like electrical energy transmission system, like electromechanical system such as the generator and the alternators, solar power converters, energy storage devices and batteries, fuel cell and other power supplies we use for the various instrument or various electronic gadgets. So there are the two types of power supply existed where we discuss that one is the AC and second is the DC power supply. One is the AC power supply and second is the DC power supply. Based on the electrical devices, electric specifications, it may use the AC or DC power supply. It depends upon the what type of electrical devices we are using, the AC or DC. On the basis of that, we use the AC power supply or the DC power supply. It means it is further divided into the many parts. So first we discuss the definition of the power supply. What is this power supply? How we define the power supply? Basically it is an electrical device which is used to give electrical supply to the electrical loads to the system. The main function of this device is to change the electrical current from a source to the accurate voltage, frequency and the current to the supply to the load. It means power supply works to give the electrical supply to the electric load. Sometimes these power supplies can be named as the electric power converters because it supply the electrical loads to the electrical devices. Some type of the supplies are separated pieces of the loads, whereas others are fabricated into the appliances that they control. So power supply is one type of the unit that gives the electrical supply to the electrical loads. The power supply circuit is used in the various electrical and electronic devices. The power supply circuits are classified into different types based on the power they utilize for providing the circuit or devices. For example, if we take the microcontroller based circuits, so generally we use the 5-volt DC regulator power supply there, RPS, and in the laboratories we also use this circuit. So 5-volt DC regulated power supply we use in the microcontroller, which can be designed with the help of the different methods for changing the power from 230 volt to the 5-volt DC, 230 volt AC to 5-volt DC. So power supply we use on the basis of its requirement. How we select the power supply for a particular devices? So there are some steps when we choosing a power supply. There are several requirements that need to be considered. The first is power requirement of the load or the circuit, or including the voltage or current that we require from the power supply. So these are the requirement. Another is a safety feature such as the voltage and the current limits to protect the load. Physical size and efficiency we require. Sometime when we use the power supply, the noise immunity of the system should be less. Here we see the framework of the power supply. We use the main input, then we transform into the power, then we use the rectifier, then smoothing the system, and then it will go the output. So these are the framework of the power supply. Start from the main input, power transform, rectifier, smoothing, and then output wherever you required. So power supply can be classified. There are various types of power supply, but how we classify this power supply? So we classify these power supply into the various categories which based on the different criteria. What these criteria are? On the basis of design, on the basis of voltage level, on the basis of application, and many more, which on the basis of that we define the various category or the various classification of the power supply. Here we classify the power supply on the basis of some factors. First, if we classify on the basis of the design, we classify the power supply based on the design. There are two types of power supply. One is the linear power supplies and second is the switching power supplies, that is also called the SMPS. So first is linear power supply. These power supply use a linear regulator to regulate the output voltage. As the name suggests, linear, so we use a linear regulator and to regulate the output voltage, and they are known as for their simplicity and the low noise operation. And further we will discuss about this in detail, but this type of linear power device which supplies use a linear regulator to regulate the output voltage. Second type is a switching power supply, that is SMPS. Switching power supply use the high frequency switching devices like the transistors to regulate the output voltage. Previously we use the linear regulators to regulate the output voltage. Here we use the transistors to regulate the output voltage. So they are more efficient but can be more complex as compared to the linear power supply. So on the basis of the design, we classify the power supply into two ways: linear power supply and the switching power supplies. On the basis of the voltage output, how we classify the power supply? Again we have the various type. One is the single output power supply and second is the multiple output power supply. On the basis, as the name suggests, voltage output. So we, for the single output power supply means these provide a single fixed output voltage. But here in the multiple output power supply, these provide the multiple output voltage, often for the different purposes within a single devices. But the variation of the voltage is there as an output. You know that sometimes we require the we supply the voltage, very different voltage to the instrument, then we will use the multiple output power supply there. On the basis of voltage, we have two forms: single output and second is the multiple output, where the single output where we fix the voltage output, and second multiple output where we can vary the multiple outputs, we can have multiple voltage we can have in this type of the power supply. On the basis of application, we differentiate the we classify the power supply. First is AC-DC power supply. Second is a DC-DC converters. What is AC to DC power supply? Which converts the alternate current into the direct current. So commonly used for the electronic circuit that run on the DC power. And second, DC to DC converter, that convert one DC voltage level into the another DC voltage level, often used to step up or the step down voltage level, that you have listened in your laboratories that we are using the step up and the step down voltage. So AC on the basis of application, AC DC power supplies which convert AC into DC, and DC to DC which convert DC voltage into the another DC voltage level, that is step up and step down. Next is the based upon the output regulation, how we differentiate the power supply. First is the fixed voltage power supplies which provides the constant output voltage regarding of the load variation. matlab means we are having the various load changes in this battery, but the output will be the constant voltage. So fixed voltage power supply. Next is a adjustable voltage power supply. It means it allow the user to manually adjust the output voltage within a specified range. So based upon the output regulation, we have the fixed voltage and the adjustable voltage power supplies. Another one is the uninterruptible power supplies, that is also called the UPS, that you also have with the UPS you have with your computer system. So that provide the backup power during the electrical outages to ensure the continuous operation of the critical equipments. As the UPS you all seen with with the computer or the desktop setup, you see the UPS we use that have the backup power, so that it can be used when the light off. So another type of power supply is the battery chargers, that specifically we have the design to change the batteries efficiently and safely. That are the battery chargers that we always use in the daily life, that type of battery chargers. Lab power supplies. In the laboratories we use the prototype of electronic circuit, where we use the variable power supply that is used in the laboratories for testing and prototyping the electronic circuits. So these are these based upon the output regulation. First is the fixed voltage, second is the adjustable voltage, third is the uninterruptible, the fourth is the battery chargers, and fifth is the lab power supplies. So these are the various type of the power supplies. On the base of the isolation, how we differentiate the power supply? First is the isolated and second is the non-isolated power supply. In the isolated power supply, that type of isolated power supply provide the electrical isolation between the input and output, often used in the application where the safety and the noise isolation are essential. So it provides this type of isolation power supply provide the electrical isolation between the input and output. Another one is a non-isolation power supply. They do not provide the electrical isolation and are typically used in the low risk applications. Next is the we differentiate the power supply on the basis of the size and the form factors. Like bench top power supplies designed for use for the work bench or the lab tables. These type of power supply used in the laboratories that we use for the work benches. So that is bench top power supply. Next is the rack mountable power supply, that is designed also for install in the standard equipment racks, so that we can use for the like inverter. That is also the power supply that we design for install in standard equipment racks. Based upon the specialized feature, we have various type of power supply. First is a programmable power supply that allow the user to program the voltage and current setting for the automatic testing. It means whenever we use the variation of the current or use the variation in the voltage, then we use this type of specialized feature like the programmable power supplies, which allows to user to program voltage and current settings for the automatic testing. Another type of specialized features power supply is high voltage power supplies. High voltage means it provides the high voltages for specified application. If we have some specialized applications or where we use the high output voltage, then we use the high voltage power supply. Another type of power supply is a medical power supply, that is designed to meet the medical safety standards and the requirements. On the basis of that, the power supply designed so that it can be medically used in a safety manner. Another type of power supply is the industrial power supply, built for the rugged environment and often has enhanced production features. So we use the another type of the industrial power supply. So each classification has its own uniqueness, and they are having the unique various characteristics and application. So the choice of the power supply depends on the specific requirements of the electronic devices or the system, and it is intended to the power. So whenever we choose the power supply, then we have to see its features, its output and its variation. So power supply for a specific uh, instrument will be designed. So these are the various classification. We will discuss one by one of these classification. Before discussing the various power supply one by one, first we discuss the what are the principle of power supply, on what principle and what features required for the power supply. If we talk about the principle of the power supply, that involves a fundamental concept and the components that enable the conversion of the electrical energy from one form to the another form. Like if we have the input source, that may be the AC or DC, to a regulated output voltage or the current that is suitable for the powering electronic devices. So here we are having the various key features of the power supply principles. What are the principles behind it? First principle is the input voltage sources. Power supply starts with an input voltage source, so which can be either AC or DC. The input voltage can vary depending on the application or the reason, but it is often standardized for the specific devices. So before starting the various power supply, before using this, the power supply start with an input voltage sources. It may be the AC or it may be the DC, and the voltage can vary depending on the application and the reason, but it often standardized for the specific devices. Next principle is the conversion. The primary function of the power supply is to convert the input voltage to the desired output voltage or the current. So the conversion process is achieved through the various components and techniques. So we keep it in the mind that conversion is also important. Next is transforming AC to AC. In case then we are giving a input in the AC, and output will also come in the AC. So in cases where the input is AC, a transformer may use to step up or step down the voltage and depending on the required output voltage. Next is rectification, that is AC to DC. Input we are giving AC and output we are getting the DC. So rectification is used to convert the AC to pulsating DC. So this typically done using the diode or the bridge rectifier configuration. This means when we use the AC to DC conversion, then we use the bridge rectifier. Another is the filtering. After rectification, filtering components such as capacitors are used to smooth the pulsating DC, resulting in the relative stable DC voltage. So the filtering is also an important part. Voltage regulation. Power supplies often include voltage regulation circuits to ensure that the output voltage remains constant even with the variation in the input voltage or the load. Next feature is the output voltage and the current regulation. It means output is also output is very important in case of the power supplies. So power supply has a mechanism to regulate the output voltage or the current to maintain it at a specific level. So even when the input voltage or the load conditions changes, the output the regulation can achieved using various techniques including feedback or the control loops. So output voltage or current regulation is the when the input voltage or the load condition changes. This regulation can be achieved using the various techniques. Next feature is the protection features. So power supply include the safety and the protection mechanism to prevent the damage to the power supply or connecting devices. So common protection features include the overcurrent protection or the over voltage protection and the short circuit protection. So these protection are main features in the power supply. First is the overcurrent protection, second is the over voltage protection, and third is the short circuit protection. Next important feature is the efficiency. A good power supply operates with a high efficiency, means conversion as much as the input we are receiving, so no losses, means minimizing the losses, and the efficiency is more as compared to as we are giving the input, so output we will get as a desired result, because if the losses should be minimum. So a good power supply operates with the high efficiency that convert much of the input power supply as possible desired output with the minimum loss. Next is the isolation option, that is optional, but that is also an important part when we talk about the isolation power supplies and non-isolation power supply. In such applications, especially those involving the safety or noise consideration, power supply may provide the electrical isolation between the input and output to prevent the unwanted interaction or the electrical hazards. So next feature is the control and the monitoring. So modern power supplies often include the control interfaces and monitoring capabilities. So users can adjust the output voltage or the current through the controllers, or some power supplies may often programmability for automated testing or the system integration. So control and monitoring is also a important feature. Next important feature is the cooling and thermal management. So in the power supply, generate heat during the operation. So effective cooling and the thermal management are essential to prevent overheating and ensure reliable performances. And that cooling, you see sometimes we use the small fans in the power supply, so that simultaneously it will avoid the heating of the instrument. So power supply generate the heating during the operation, so effective cooling and the thermal management are essential to prevent the overheating. And next is the size and the form factor. Size is also important, as we depend upon the size of the electronic gadget. So power supply come in the various sizes and forms factors, so including the desktop units, rack mounted units, and integrated power supply within the electronic devices. As per the requirement, the size may vary. Another important feature is the application specific consideration, that where we are using the power supply, where maybe in the industrial machinery, maybe in the medical equipment or the other specialized uses. So application specific consideration is also the feature. The design and the principle of the power supply can vary depending on the intended application where it is consumed, like in the electronic circuit and medical equipment or the industrial purpose. Understanding these principles is crucial when designing or selecting a power supply for a specific application to ensure that it meets the required for the voltage, current, efficiency and safety. The main thing is without damaging the without any loss, the efficiency of any power supply should be more, as it will work in the good manner. What are the important specification of the power supply? While all the power supply specifications are valuable, some of more critical than others. A few specification of the note we can discuss, like output current, like load regulation, that we will discuss in the further lecture. Thank you very much.